In every frame that we need to display, the main rendering function invokes the model level rendering function, which draws the object encapsulated by the model class. We start by binding vertex array of this model, which activates the object state in the GPU. Likewise, we call GLUseProgram to activate the shader program that belongs to our model. Since this is done at every frame, you can change the shaders, meaning that you can be using any shaders while the application is running. For vertices, normals, and colors, we must enable the vertex attribute arrays in the vertex shader, that is the vertex shader input variables, like these over here, input position and input color. Then we also have to enable vertex attribute array to activate position, normal, and color input variables in the shader. We also have some additional texture related calls like enable texture, bind texture, specify active texture ID, and then set the texture sampler in the uniform. We will discuss this part of setup when we go over the topic of texturing in detail. For model matrix, we call GLUniform matrix and pass the address of the matrix as a parameter. For the rotation matrix that captures rotation of normal vectors, we call the GLUniform matrix the same way. If a pointer to the light object is present, we also make a uniform call to set the light vector in the corresponding shader uniform variable. And then we call GLDrawElements in case if index array is present, or otherwise we call GLDrawArrays to draw triangles directly from our vertex attribute buffer input. Finally, as the drawing process of the object encapsulated by our model nears completion, we call disable vertex attribute array to make the shader ready to accept the input from the next model, and so on until all models are rendered.